This is a diagram of your brain taken from the text 3.18. I added central sulcus.
You'll also notice from that picture that the brain's divided into four regions. And in fact, there really are two primary functions in the brain. The part that's carried out just in front of the central sulcus is where you move your body. There's a little map of the body on there, and so if you electrically stimulate the area that's where the foot is, the foot will move. And in fact, it's that area that controls the foot that you will use to make the soccer kick. Just in front of that is the premotor area, and that is where you adjust the rest of the body in order to make sure you don't fall down, unless that was intended, when you make that kick. And in front of that, at the very tip here, is where you have the understanding that if you make that kick, it might win the World Cup for your team and make you a famous and rich person. Now contrast that with what's behind that central sulcus. Again, look at the diagram. These other three regions are either the body senses, just behind it, or way in the back, the vision you're using to look at this clip, or down in the temporal lobe area, the audition that you're using to hear the words. And these things get combined. In this moment, you are combining my words with the face that I'm projecting here and the movement of the lips in order to get a whole integrated impression. And that's a polysensory region that's representing me, the sound of my voice, what I look like. And that basically is the job of these three regions, to understand the world. So this is very simple. The back part of the brain understands the world, forms objects that have many sensory components to them. The front understands what you're going to do, how you're going to act, possibly with that object. Will you come up and talk to your professor today? And what is the significance of that when you get up to the frontal lobes? By the way, here's a fun fact. If you measure many brain regions and scale them up from, let's say, the size of a laboratory rat to our size, they scale up pretty well. The frontal cortex is 2.5 times larger in us than it is in rats, suggesting a very different dedication of real estate in the brain to function. We really plan much more than animals. The brain also has internal structures. Let's take a look at a few.
Here's some showing the hypothalamus, amygdala, and hippocampus in this drawing, and this one focusing on the substantia nigra and the VTA, but also revealing a lot of internal structures, of which there are many, many more than these 5 featured here.
We're going to come back to the internal structures when we talk about various functions inside the head and consider levels of function, which I'm going to save for a separate video, but basically is how the brain is built from the bottom up. That points out that what you saw in the first part of this video was really the crowning achievement of evolution, the highest cognitive function in terms of analysis and thinking and planning and even speech, the cerebral cortex. I said when I opened this video that here's your brain, but what I really meant was here's your cerebral cortex, the outer covering of the brain, the part that makes you smart, the part that makes you human, the part that makes you really interesting to Psych 1.